Hello everyone, welcome back to my channel, your channel, our channel, Mr. Causes Infinity. It has been a while, I hope you missed me. Okay, but today we'll be talking on determination of area of plane figures using integration. Determination of area of plane figures using integration. You see, mathematics only becomes useful and vital when we are able to use it in solving real life problems or in demonstrating real life aspects. So today I'm going to be using the notion of integration in order to demonstrate or to derive the formula for area of plane figures. And we have plane figures like squares, rectangles, triangles, trapezium, and circles. So I'm going to start with the first case will be area of rectangle. We all know that a rectangle is a figure like this, which from here to here we can give it a value, say A, and from here to here can give it a value, say B. Now, our goal here will be putting this figure on a reference frame of y against x. Then if I say from here is 0, then 0 to this level is B. So if you say 0 to a certain level here, we call it B. And we draw a line. So now, and we have our x, which is from 0 to A. 0 to A, we can say A is here. We call this A. Now you see that this already forms a rectangle. So we have placed this our rectangle on a reference plane like this. Now, how do we get the area of this figure? We know the area will be equal to the integral of f of x dx from 0 to a. But now, what is f of x? F of x is equal to y, which is equal to b. So you see that the function here is a function independent of the variable x. So now we are going to replace it in this our formula in order to have the area. Now we say area is equal to integral 0 to a of b dx. Now integrating this, I'm going to have dx 0 to a. So therefore this is area equals to bx 0 a. Now replacing the limit from 0 to a, we start with upper limit minus the lower limit. Our lower limit is 0, so it will be useless replacing it. So this implies our area of the rectangle is equal to b times a. And now, our value of b here is our width, and our a is our length. So we are going to say, therefore, area of rectangle is equal to length times width. So you can all see where the idea of area of rectangle being length times width comes about. Integration of a function y equals to b from 0 to a, and we have this. For a triangle, it is a bit complex, not like for a rectangle. So we know that the shape of a triangle, we are taking a right angle triangle, please. Something like this. Yeah. Where we have a certain height and we have a certain base. Okay. But now our first goal here is to place this shape on a reference frame. So how do we do that? Now placing this shape on the reference frame will depend solely on this line. So it means the function we'll be dealing with here is a function of a straight line. So how do we place this on the reference frame? I'm going to use a red pen in this case and blue pen. This line here is it, which is our function. So, and this is our y, our x. Now, from 0 to b, You can see this is 0, and you can see our B is here. So it has to close. And from now, the right angle triangle. Then now, how do we get the area of this right angle triangle? Still the same principle. The area is equals to the integral from 0 to b of f of x dx. But now, what is f of x? F of x is an equation of a straight line with the intercept at 0. So, say f of x is equals to mx plus c, where c 0, as you can see. But now, how do we get m? Which is y2 minus y1 all over, okay, let me locate, okay. So now, what is our y2? Our y2 is h, and our, okay, so we are going to say the m, which is h minus 0 all over x2, which is b minus 0. So therefore, m is equals to h on b. So now, how do we write the equation of the function? So we say our f of x is equals to, come back here, we already set c is equals to 0, and now we set m is equals to h on b. So f of x is equals to h on bx. This is the function we are going to be integrating. Okay. So we are going to say, our area is equals to integral from 0 to b of f of x. But our f of x is equals to h on bx dx. So therefore, area is equals to, we are going to remove this out since it's a constant. Integral from, oh, x, yes, x dx. Good. Now when you integrate x, we have x squared on 2. So this implies that area is equals to h b x squared on 2. We are integrating from 0 to b. So replacing the value of our upper and our lower boundary is already 0. So we are just going to focus on our upper boundary. So therefore, area is equals to h on b into b squared on 2. So b will cancel b, and we are left with area equals to half, because of this 2, height times base. So we see how the formula of area of a triangle, of a right angle triangle, is gotten using integration. Hope it's okay. Okay, so we are at the level of a trapezium now. So what does a trapezium looks like? I'll just do a sketch of a trapezium. So a trapezium is a combination of triangle and rectangle. So this is just what I was talking about. Then now, how do we get the area of a trapezium? It becomes a little bit easier, but technical. So I'll just have to put it on my reference plane of y against x. Okay, as you can see, I have represented the trapezium on a reference frame. So we see the dimension 0 to a for the first triangle, a to b for the rectangle, b to c for the next triangle. Now, since this is already a combination of a triangle, of two triangles and a rectangle, I can call this one 1, 2, and 3. So the area equals to area of 1 plus area of 2 plus area of 3. Okay, so since we already know the formula to get area of 1 and that of 2 and that of 3, it becomes very easier now. Because here we are just going to be using the previous knowledge from the area of a triangle and that of a rectangle. So it means A1. So now you can see that the area of the surface 1 is equal to half A times height. How was this obtained? Let's go back to area of a right angle triangle, where I said A is equals to h on b, integral from 0 to b, x dx. But at this level, you see that we are integrating from 0 to a. So that is why A has replaced B. Okay, so that's why we are now having area of surface 1 equals to half A ish. Now let's come to the next triangle, which is surface 3. Said A3 is equals to half in bracket C minus B ish. Okay, if you look here, we said it is base times height. Our base here is BC. So it means it is actually C minus B to have this base times the height. Or better still, if you are to use integration, let's go back up here. It actually means you'll be integrating from B to C. And when you want to start replacing the limit, you are going to replace C first before B. So it means we are going to have C minus B H. Now at the level of the rectangle, we know the formula for the rectangle is length times the width. So if you look here, we have B minus A, which is the distance from here to here. And our height and our distance here is H. So we are going to take B minus A times H to have A2. So A2 is equals to B minus A times H. And I said the total area of the trapezium is equals to area of surface 1 plus that of surface 2 plus that of surface 3. Since we have all what we need, we are going to replace it in the formula. So it becomes half A-ish plus B minus A bracket H plus half C minus B-ish. And now we are just going to expand our bracket. When we expand our bracket, we are going to have B-ish minus A-ish plus half C-ish minus half B-ish. Okay, so after opening the bracket, we are going to have something like this. Now, if you look keenly, you are going to see that we have BH. BH minus half BH is equals to half BH. And now we have half AH minus AH, which is equals to minus half AH plus half CH. Here is it. So now if you look all three, you see that half is common and H is common. So when we factorize, we are going to have B minus A plus C. So as we have B minus A plus C, if you look on the drawing here, B minus A, here is the distance. So we can call this distance, let's just say the distance is something like capital A. You see, since we have an A, which is our area, so I don't think we are going to use again A here. So it's better we use L. So we are going to say the distance from A to B, which is B minus A, is L. So we have B minus A implies A is equal to half H into B minus A, we said it is our L plus C. Now what is our C? So you see that C is actually the distance from here to here. That's why we call it C. So this is the area of a trapezium. Half H in bracket L plus C. And that is just it. If you like, you check anywhere, you're going to see the area of a trapezium as this. Oh, I'm all exhausted. Really tired. Hope you are not bored. Okay. Okay, now we are at the level of a circle. And this is a circle with an angle at this level theta and 0 pi on 2. So if our angle is here theta, and we actually call this one x, we call this y, then it means our x is equals to arrow sine theta and our y is equals to arrow cos theta. So automatically, you do the mathematics, you see that x squared plus y squared is equals to arrow squared. And if we are going to look at the area just of this shaded part, then we have to multiply it by 4 because we have divided it into 4 parts and we are looking at the area only of this part. So the area of this whole circle will be the area of this part. So it means our area here is equal to 4 integral from 0 to r, which is our radius, of y dx. 4 because we have divided this section into 4 parts, as you can see. So now, we said our y is equal to r cos theta. So we are going to replace it. So it becomes area is equal to 4 from 0 to r cos theta for y, and our dx. But we cannot integrate theta with respect to x. So we have to change the variable. How do we do that? Now our x is equals to arrow sine theta. So this implies that dx is equals to arrow cos theta d theta. Now I'm going to take this expression and replace it in the formula there. So it becomes a is equals to 4 integral 0 to pi on 2. Why pi on 2? We are leaving from 0 to pi on 2 and from pi on 2 to pi and so on so that you can form a 360. So to pi on 2 cos okay 0 to pi on 2, excuse me, arrow cos theta dot arrow cos theta d theta, because all of this is equal to dx. Arrow times arrow gives us arrow squared. Cos theta times cos theta gives us cos squared theta d theta. But now, how do we integrate cos squared theta? We all know that 2 cos squared theta minus 1 is equal to cos 2 theta. So cos squared theta is equal to cos 2 theta plus 1 on 2. We are going to replace this in the expression. Area is equal to 4 radius squared, integral from 0 to pi on 2, cos squared theta replaced by cos 2 theta plus 1 on 2 d theta. 2 is going to cancel with 4, and we are going to have 2 here. So the expression will be simplified now to a equals to 2 radius squared, integral of cos 2 theta plus 1 d theta. Now, when you integrate cos 2 theta, we have sin 2 theta on 2. And when you integrate 1, we have theta. So from 0 to pi on 2. Now, replacing our limit, pi on 2 in this expression minus 0 in this expression. Sine 2 pi on 2 is the same as sine pi, which is 0, plus pi on 2 minus sine 0, which is 0, plus 0. So when I replace it here, my boundaries pi on from 0 to pi on 2, I'm going to have just pi on 2, making that the expression will become area equals to 2 radius squared, this 2 radius squared, times pi on 2. Now 2 is going to cancel with 2, and you're going to have area equals to pi radius. So I said, man, cut the video now. We have come to the end. Okay, we have come, you don't want to cut the video. Okay, let's just round it up, please. Okay, today we did determination of the area of plane figures like rectangle, circles, trapezium, and triangles using integration. So please don't forget to like, subscribe, and even share to your friend who has another friend so that the family should keep on increasing. And I'll be waiting for your comments. Like you can just comment below requesting that I should do a video to talk about this particular aspect. I'm going to be glad hearing that from you. And in fact, cut the video this month. The positive infinity. Happy Easter. So try to post now and see if you are